Good afternoon. Let's get started. Our talk next week is actually a panel discussion where we'll talk about renewables in Texas, and we'll have three great panelists: Clay Butler from the Butler Firm, Colin Meehan from First Solar, and Spivey Pop from Eon Renewables. Our speaker today is Professor Steve Fuller, who is an associate professor at the Texas A&M University in the Department of Economics there, and he's also a research associate at the National Bureau of Economic Research, or NBER. His primary research is in the area of industrial organization with a focus on energy markets, especially looking at the electricity and transportation sectors. His recent research has been discussed in, received wide media coverage, including in Forbes, Wall Street Journal, and other media outlets. He has served as a visiting research associate at the University of California Energy Institute, and also done some very exciting work, including the one that we'll talk about on transportation. He has been an advisor at the Public Utility Commission of Texas, PUCT. He received his bachelor's degree from the University of Chicago and a PhD from the University of California, Berkeley. We're so pleased you could join us, Steve, today.
Great.
Please join me in welcoming Steve.
I thought really appreciate the invite. For those of you guys that have the opportunity to come to this often, you're actually really lucky. I'm quite jealous that you guys have a forum like this. What I like about it is that the research on energy is inherently interdisciplinary, and so sometimes there's silos where this discipline does things this way and another discipline does them another way, and kind of having a forum like this for people to get together from different disciplines is really valuable, and I'm jealous. But thanks for the invite. I work in both electricity and transportation, and I'm going to talk about the transportation-related work today, and in particular a couple of projects I've been doing with some of my colleagues that have analyzed programs to basically try and make the personal vehicle fleet more fuel efficient, and then to think about what the efficacy of those programs are, and in particular, if you were in the future, there are various policies in place that put households in more fuel-efficient cars. What are some of the implications? I should acknowledge my colleagues. This is I'm going to talk about two different projects and allude to a couple of others as well, with some colleagues at A&M, Mark Hoekstra and Jonathan Meir, who are in my department, and Jeremy West, who's a former graduate student who's just starting a postdoc at MIT. So why study personal vehicles? This is probably not something that surprises anybody in the room here. But the emissions from personal vehicles are a major contributor to greenhouse gas emissions. The two major sectors that contribute greenhouse gas emissions in the U.S. are electricity and transportation. And among the and they're roughly kind of a third-ish each. And among transportation, about over half is coming from light-duty vehicles, or kind of the things we drive around, not the fleets. And so understanding determinants of what cars we buy and how much we use the cars that we buy is important for climate reasons. And then more generally, there are a lot of other externalities associated with driving. So I'm an economist, so I tend to get hung up on things like externalities, which basically means there are these costs borne by the people that drive that aren't borne by other people. And so, in terms of personal driving, it's not only climate change, but it's also local emissions of NOx that in some areas contributes to ground level ozone concentrations, vehicle accidents, road congestion, and energy security. And the standard kind of economist take on things is that if the amount of these externalities is not internalized into either the price of auto insurance or the price of driving on a road at a given point in time or the price of oil, then there's room for policy intervention in order to kind of correct the fact that these externalities are not being internalized. And one form of this type of intervention can be vehicle scrappage programs. And so there are a couple of these programs. They come in different flavors. They're both statewide programs. They're local area programs. For example, Houston and the DFW area have scrappage programs. And there's also been a particularly large national program, which is what I'm going to focus on this afternoon. They come in different flavors, but essentially the idea is you're basically subsidizing people to take their old maybe fuel inefficient, probably high emitting vehicles off the road, and you're subsidizing them to buy new or at least new-ish cars that are likely to be either more fuel efficient or lower emissions. And one of the reasons we like studying these scrappage programs is we think that this gives a nice lens into kind of probably what the major program is that affects fuel economy, and that's the corporate average fuel economy standards. As many of you guys may know, the U.S. recently updated these standards, and so the projection at least is by 2025, the new vehicles sold in that year are going to have a fuel economy averaging over 50 miles a gallon. So pretty dramatic change. And so to the extent that we think that's actually going to happen, trying to look at what's going to happen, how much people are going to drive when you put them in more fuel efficient and perhaps smaller cars, we think has important policy implications. And we want to look at that. And we're going to use these scrappage programs, one in particular, to try and analyze that. So we're going to study the Federal Cash for Clunkers program, which you guys probably remember. Some of you may have participated in this program. This is basically an economic stimulus program. It was a $3 billion program during 2 months, the summer of 2009. So this was kind of during the depths of the Great Recession. And it was a program that, well, here, let me give you details of the program. The primary goal, one could debate about what the goal of the program is, but I think if you read a lot of kind of legislative intent, what you'll come out with is the sense that this was a stimulus program. So the auto industry, a couple of manufacturers in particular, were in a lot of trouble. Sales had dipped quite a bit. And so the idea was, can we, by subsidizing sales of new cars, help auto manufacturers and the suppliers of those assembly plants pull forward sales? And in the language of the chair of the Council of Economic Advisors at the time, from future periods when the economy is likely to be stronger to the present. So largely a stimulus policy to direct revenues to the auto industry. And then a secondary goal that was kind of added on was that the new cars that had to be bought needed to be fuel efficient, and so that might improve the fuel economy of the fleet and reduce gasoline consumption and emissions and other externalities that are associated with gasoline consumption. So what we're going to do as kind of researchers is 2 questions. So this is, honestly, this is 2 papers I'm bundling into one, but hopefully it'll all kind of fit. The 2 questions we're going to look at is we're going to ask what the effect of putting people in more fuel-efficient cars is on gasoline consumption. And in the energy efficiency literature, this is the so-called rebound effect. So the idea is if you put people in more fuel-efficient cars, so the price of driving a mile is the price of gasoline over the fuel economy. So if you increase the fuel economy, the denominator, you've just reduced the price of driving a mile. So the concern with the rebound effect is that when you reduce the price, when you increase fuel economy, say by 10%, you may not get a 10% decrease in gasoline consumption because people are going to say, hey, the price of driving a mile just went down, I'm going to drive more, right? And so we're going to see if we can say anything about this rebound effect. And the second thing we're going to look at is kind of analyze how well the program achieved its goal of stimulating auto sales, and ask the question as to what extent did it actually increase revenues of the auto industry during that short time period that it was targeting. Okay? So let me focus on question 1 first, kind of the fuel efficiency question. So here are the critical details of the program that are critical for what we're doing. Just to remind everybody. So basically this was a 2-month program. It was actually a $3 billion program, and as soon as the money ran out, it was done. Ended up lasting about 8 weeks. And the key thing is you had to purchase a new car, right? Because this is to stimulate auto sales, new car sales. And you had to literally scrap the clunker. There were about, across the U.S., a little under 700,000 trades. 43,000 of these are Texas. The ones we're going to study, as you'll see in a second, are Texas transactions. And the fuel efficiency, or the environmental component of the program, was that basically your car that you turned in, your clunker, had to be rated at 18 mpg or less, and the new car you bought had to have a fuel economy of more than 22. And then depending on the difference in fuel economy between the clunker you turned in and the new car you bought, if it was greater than 10, you got a subsidy of $4,500. If it was greater than 4, you got $3,500. And I think the mean subsidy was around $4,200. So you got a decent number of, car improvements in at least rated fuel economy of around 10 miles per gallon or more. So the first question we're going to look at is the fuel efficiency question. And the idea is, does giving people exogenously, this is a term economists like to throw around, I apologize for this, but I'll tell you why I'm kind of obsessing about this term, does exogenously giving households more fuel-efficient cars cause them to drive more, which is basically what the rebound effect question is all about. The rebound effect, as you guys know, has been around for quite a while. There was a New Yorker article by David Owen that came out a couple of years ago that kind of revitalized this, at least in terms of the intelligentsia media or whatever, however you want to think about it. And then there was a response that came out in Nature last year by a couple of economists, Ken Gillingham and Dave Rabson, that basically said, we shouldn't worry too much of this big rebound effect that's basically going to undo some of the fuel savings that you would get from fuel efficiency improvements. And so you shouldn't worry about there being truly a backfire effect. We're going to focus on, you guys know all about the different types of rebound effects. We're going to focus on one particular component of that. If you're into the rebound effect, we're measuring the direct rebound effect. So here is essentially what you would like to do. So if I could run an experiment, in kind of the traditional kind of, lab type setting or whatever, right? What I'd like to do is I'd like to find a bunch of households that were ready to buy new cars and then randomly give some of them high fuel economy cars and some low fuel economy cars, and then watch them for a couple years and see how much they drive, right? That's the way you do it. NSF so far has not offered to give me, hundreds of millions of dollars to run that field experiment. So kind of the next best thing is we have to go out and get data on actual purchase decisions that people made, okay? Now the problem with that is kind of, does correlation equal causality, right? So if I see people that are driving more fuel efficient cars also driving more, are they driving more because the price of driving a mile just went down? Or is it that they actually have a long commute, unknown to me as the analyst, and that's the reason they bought the more fuel-efficient cars? So the causal error goes a different way. Now you might think, okay, we can overcome this problem if we kind of get a panel of repeated cross-sections of households and see them over time, but you really can't get around that problem. So then, even if I see a household drive more in a particular year after they buy a more fuel-efficient car, it could be because, unobserved to me, they changed their job and they had to commute more, and that's the real reason they bought a more fuel-efficient car. So our claim is that even if you get really detailed household level data, if you try and use traditional kind of regression fixed effects types of techniques, you're always going to worry about these confounding effects, and you're always going to worry that your estimates are going to be biased. I'm not saying that papers haven't been written that way. I'm not saying that I haven't even written a paper like that, but you're still going to be worried about those types of biases. So what we've come up with is what we think is actually a better empirical strategy, which is called regression discontinuity. It's used in different disciplines. Some of you might come up from a discipline that doesn't use it. I'll explain what it is in a second. But basically, it's a way to overcome these fundamental problem of there being confounding effects. The data we're going to use for both of the two papers, basically we have restricted access to Texas DMV data. So what that basically means is we can see for a given household how the household's vehicle fleet has evolved over time. And this is for all households in Texas. So we can basically see over 7 years, technically, the buying and the exit and entry of new vehicles in a particular household's vehicle fleet. And we use the VIN numbers from this, the 17-digit number that all of our cars have, to decode and basically come up with characteristics of fuel economy, age, MSRP, and things like that. We know when the transactions occurred or the registration records occurred at DMV, so we can kind of trace how the fleet changes, and we know when people buy new cars and get rid of old cars. And then we also link this to data from the annual smog check test that many of us, we don't do this in College Station actually, but you guys do, that the TCQ has. And so what we're going to do is, for purposes of analyzing this, is we're going to basically need to say, to use this regression discontinuity technique, what each household's clunker is. And what that basically means is if you were to get a new car and therefore get rid of one of your existing cars, which would that car be? And so for simplicity, we're going to basically assume it's the oldest vehicle in your fleet, the one that you have owned, literally the oldest vehicle in the fleet. We've done fancier things, and we basically get similar answers, actually very similar answers. So we're just going to define a clunker in that way. Okay, so this technique, regression discontinuity, I'm sure probably some people in the room have seen it, so apologies if this is just repetitive, but essentially, so what is this technique? So what we would like, so go back to the ideal experiment. What you'd like to do is you would like to get rid of those confounding issues. What you'd like to do is you'd like to see two otherwise identical households. And one of them just happens to get a car, a high fuel efficiency car, and one just happens to get a low fuel efficiency car. All right? So how can you do that? Well, imagine that there's some policy in place, for example, Cash for Clunkers, that at some discrete level of your clunker, the MPG of the car that you've had, you become eligible to have this program, right? So imagine thought exercise. Let's say that MPG was a continuously valued variable, so it doesn't occur in integers, right? So what you'd want to do is you'd like to compare, so 18 or less made you eligible for the program. So you'd like to, so for the guy who's just 18 and eligible for the program, what would that guy have done otherwise if he didn't have the program? So we're going to compare him to another guy whose fuel economy is 18.1, if that existed, or 18.01 to make it more extreme, right? And the idea is that basically those guys, there's no difference between the 18.1 and the 18.01, except for the fact that discretely they were eligible for the program. Okay? So what that means is if we want to figure out a guy who is barely eligible for the program and how that affects any outcome measure, so this can be how much they drive, this can be the probability of buying a car, any sort of outcome we're interested in, then what we're going to do to figure out what this guy would have done if there hadn't been a program, we're going to look down at this guy. And this vertical distance here is going to be the estimate of the effect of being eligible for the program. All right, so that's the intuition. The technical assumption is that all determinants of the outcome measure are smooth through the discontinuity, but I think you get the gist of it. So what I'm going to do is I'm going to show you just a bunch of pictures, really. That's all I've really got to show you. There's a regression-based way to estimate this in a more flexible way, but really I'm just going to show you a bunch of pictures where this vertical distance here, 5 in this made-up example here, this 5 here is what the effect of being eligible for the program is. Okay. All right, so first, the question of the rebound effect. So you randomly give people more fuel-efficient cars. Do they drive more? So what this is the average household fuel economy. So this is a harmonic average across all the cars in the household's fleet, the year after Cash for Clunkers. Okay. And so if the Cash for Clunkers program had an effect, you'd expect those who are barely eligible to have a higher fuel economy. And in fact, that's exactly the case, right? So this is in logs. So basically, this difference here suggests that the effect of being eligible for the program is that your fuel economy was 4.6 percentage points higher. Okay, so the program had an effect. That's good. That's certainly what you'd expect to see. So now the question is, how much do they drive more or not? And here's the corresponding picture there, and here's the estimate. So this is actually not, the point estimate is actually negative, but this is not statistically different from 0. So this says, at least statistically, those households that are quasi-randomly have more fuel-efficient cars do not drive more. So this would say that there's no rebound effect in the sense that I've been talking about it. So then the question is, what's the effect on gasoline consumption? And the effect on gasoline consumption is that it decreases gasoline consumption. So you put people in these more fuel-efficient cars, they do not drive more, so therefore gasoline consumption falls. So here's some tables showing this. It's fairly robust. So basically the interpretation of this is that if you buy into the regression discontinuity strategy, then households that are exogenously given more fuel-efficient cars. Now, these cars aren't just more fuel efficient. These cars are different in other ways, too. They tend to be smaller. They tend to have less power. They're less weight. So if you get hit by something, you may not, it may affect you a little bit more. So you're getting kind of this joint effect of being more fuel efficient and everything that comes along with being more fuel efficient. So like, for example, the most popular car bought in this program was not the Prius, it was the Corolla. Okay? So the joint effect of those two factors are that people do not drive more miles. So from kind of a fuel efficiency perspective, I think this is kind of a happy outcome, right? At least to the extent that in the future, with CAFE policy, people are going to be buying more fuel-efficient and smaller cars. It suggests that you're not going to see this big take-back effect where you thought you were going to get these fuel efficiency gains, and in fact you're not. Now, this is just the short run. This is just in the 2 years after the program, so we can't speak to anything in the long run, but at least in the short run, it's suggesting that you're not getting a big rebound or take-back effect. And so that's kind of the happy result. Well, if you're into energy efficiency, so that's kind of the happy result. The second question we're going to look at is kind of a less happy result, well, depending on who you are, I guess. So the question is, did the Cash for Clunkers program, stimulus program, increase or decrease new vehicle spending? So let me say a little bit more about why this program, so I'm not a policymaker, but if I were, why this might make some sense. So most stimulus programs we as economists think of as, give tax rebates to people and then, let a fiscal stimulus program let them spend it on whatever they spend it on. And then depending on your view of what the multiplier is, that can be good or bad. So this program is a stimulus program which is relatively unique in the sense that it targeted a particular industry, the auto industry, a durable good industry. And the reason to do that, and you guys probably have, we all probably have intuition for this, but just to make it really clear, so what this is in durable manufacturing, so not just cars, any durable goods, millions of workers over the 7 previous recessions before the Great Recession. And as you can see, there's a big dip in employment for during all of these recessions. Now, if you contrast that to just something else, retail trade, definitely you could see a kind of a trend break here with the recessions, but it's not nearly as dramatic here as in durable manufacturing. So at least I can imagine the political appeal of saying, let's help durable good manufacturing. Okay. So, all right, so generically you would think, so at the end of the slide you'll see where I'm going. I'm going to try and set it up here a little bit. So generically you would think that if I take an industry, yeah. Sure. My bad. Those are the recessionary periods. Those are the officially declared NBR recessionary periods. All right. So generically speaking, if there's some industry and the government is going to subsidize the purchase of goods for that industry, you might think that program would lead to more spending in that industry. Okay. So so there are 2 things, at least in the case for Cash for Clunkers, that could go wrong. Actually, let me flip it. Here's what could go right. So what could go right is if the Cash for Clunkers program induces people who otherwise would buy maybe 3 or 5 years later, post-recession, to pull their sales forward. And in fact, the Council of Economic Advisors and NHTSA, their estimates were that you'd be pulling forward sales from 3 to 5 years forward. Okay, so that would be one good thing. The second good thing would be if the types, given that people are given approximately $400 to $200 to spend on a car, they might kind of trade up in the sense and spend them on more fuel-efficient cars. They might, or more expensive cars. So maybe the Prius, or maybe in 2009, some of these makes and models had hybridized versions of it, so they might spend the extra $5,000 to get the hybrid version of an Edge, for example. Okay, so that's what could go right. So the flip side of that is what could go wrong if, in fact, the sales you're pulling forward are only from the very near future. So really you're just pulling recessionary sales to recessionary sales instead of post-recession to recession. And for some reason the households decide to purchase low-priced cars. That's what could go wrong. And I'm going to show you what I think, you can tell me what you think, is pretty convincing evidence that unfortunately both of these things went wrong. Okay? So let me first focus on, actually let me focus on the second one, the low-priced cars. So recall that Cash for Clunkers require the new cars to have a fuel economy of at least 22. In general, so this is a plot of all model year 2010 vehicles of MSRP versus MPG, and in general there's a negative relationship, right? The Corolla is cheaper than the Camry. Okay. Now let's add some Cash for Clunkers requirements. So one Cash for Clunker requirement is the car had to be less than $45,000 MSRP. The other requirement is if it were an SUV, you actually could buy an SUV, although not many people did. Most people buy cars. So you had to buy, if you were going to buy a new car, it had to have a fuel economy of greater than 22. So we're kind of restricting implicitly we're restricting to this range. Okay? Now that's not to say there aren't some high-priced cars in here. There are, for example, hybridized versions of some kind of traditional cars. But in general, you're restricting to lower-priced cars. Okay? So what we want to know is so here's basically the empirical approach. We want to know how many households would have purchased a new car if there were no program. Okay? And then given that, what that new car would be and what the price would be. So we're going to use the same kind of regression discontinuity approach. And the idea is the following. Basically, we want to look into what the parallel world would look like if there were no Cash for Clunkers program, right? So unfortunately, there's no parallel United States in a recession, blah, 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 right? But what we can do is we can look at those households that were barely eligible for the program, thus were affected or could have been affected by the program, and compare them to the barely ineligible households, the 18.01s that were not eligible, and use those 18.01s and their purchasing patterns when they purchased the price of the cars they purchased as basically a counterfactual for what would have happened to the eligibles if they hadn't bought. So standard kind of regression discontinuity approach. So we're going to estimate this in 2 steps. So basically the first is to kind of address the entire question. The first step is, like, how big was the pull forward window? Was it 2 years, 5 years, or what we're going to find is just a few months? And then conditional in that window, then we're going to look at all the people in Texas that bought new cars during that pull forward window, and then compare the price of the cars, the price paid for the barely eligible and the barely ineligible. And then that's going to tell us what the stimulus effect was. So the first step of that is to kind of calculate the pull forward window. So what this is the 2 months of the program, July and August. And this is the fraction of households buying a new car. Okay, so it's naturally going to be low. This says 0.02 if you can't see in the back. So it's not surprising that it's low, not that, in a very short period of time, not that many households are going to buy a new car. And then what we're basically comparing is how many people bought a new car for the barely eligibles versus the barely ineligibles. Okay? So during the Cash for Clunkers program, the eligibles are more likely to buy a new car during that period than the ineligibles, which makes sense. They're subsidized to do so. Right? So the question is, how long does it take for the ineligibles to catch up with the eligibles? And then as soon as they catch up, we're going to call that, hey, that's the pull forward window. Okay? So, all right, so this is the 2 months of the program. If we then take a bigger window, so a window that starts when Cash for Clunkers begins, but ends in January, so what is that, 7 months. As you can see, all households are more likely to have purchased because we've got a bigger window. And it looks like the ineligibles or the barely ineligibles are catching up with the ineligibles. So if we then increase this to 8, 9, 10, I might be off by 1. Sorry, I'm off by 1. If you increase that by whatever it was plus 1, eventually the ineligibles catch up with the eligibles. Okay. Now you can debate about whether, depending on what functional form you use to fit this, whether you think the catch-up is here or here or here. In the paper, we do robustness to all of those windows. We're going to pick this. We're going to pick this window right here, but pick whatever window you want. The results are remarkably robust to this. So now what we're going to do is we're going to take that window of time and say, all right, everybody that bought a new car in Texas during that time period, let's look at how much they paid for it and what the fuel economy was of that car. So during the Cash for Clunkers period, here's the fuel economy. So not surprisingly, those that were eligible for the program bought more fuel-efficient cars than those that weren't eligible. The program had a meaningful effect on fuel economy for all the people that were purchasing during that 10-month period. All right, so that's, I guess, good from a fuel efficiency perspective. The program had its intended effect there. Here is the MPG effect. I'm sorry, I said that wrong. Here is the Cash for Clunkers period. Here is the full 10-month window. So even during the 10-month window, there was a meaningful effect. All right, so here's the real key slides here. So what about the amount that was paid for cars for a barely eligible versus barely ineligible household? During the Cash for Clunkers period, it was a decent bit less, which basically says Corollas cost less than Camrys. Okay. Now, if we extend this to the entire 10-month pull-forward window, so that basically this is asking, during that 10-month period, everybody that bought a car, the barely eligibles spent less than those that were barely ineligible. Okay? would suggest, so basically what this is saying is, if there had not been a policy, or the counterfactual for what someone would have done, if there had been a policy, they would have spent more money than with the stimulus policy. Okay? So now if we want to convert that to see kind of how much this program reduced auto industry revenues, all these graphs I've been showing you are the effect of being eligible. Some people that are eligible didn't actually take up the program, and so what we need to do is we need to figure out how many of the people that bought a new car took up the program. It ends up being about a third difference, and then scale up proportionately. Okay? So if you do that calculation, here's basically what we find. In terms of the eligibility, being barely eligible means that you spend, barely ineligible means you weren't eligible for the program. It means you spend about this much more for new cars during that full forward window. Now, given that only about a third of those that were eligible actually took up the program, we need to scale this up by 1 over 0.37. And then once you come up with that, this up by 1.37, so what that means is that those that took up the program spent about $3,800 to $5,900 less than those than if there had been no program. Now, the reason that I'm giving you a range here is that what typically one does with regression discontinuity is you apply different types of fits to this. You have a linear fit, quadratic, cubic. Sometimes you put in controls. We want to just do all of it and basically show no matter how you fit this, you're going to get estimates that have a range but are still, fairly large numbers. All right, so I guess here's kind of the money calculation. So the money calculation, and this is some extrapolation here, because now what we're going to do is we're going to take the barely eligible and the ineligible, and we'll scale that up to all the people in Texas that bought under the program. And then if Texans are representative of the economy of the U.S. as a whole, we're going to scale that up to all 677,238 clunker trades. And what that implies is that if there had not, as a result of the program, the auto industry during that 10-month period received $2.6 to $4 billion less in revenues. So the stimulus program was basically kind of an anti-stimulus program. Now, why did this happen? Largely, well, I guess here are two things you can say. One is, if there had not been a fuel efficiency component to it, then likely this would not be, less spending. Okay. Now, one could argue that. So that's not to say there shouldn't have been a stimulus program, but it's saying if you had had the stimulus program without the fuel economy restriction on it, there would have been increased revenues to the auto industry. Now, one could argue that maybe it was worthwhile to get the increase in fuel economy, because there was an increase in fuel economy. We don't have anything to say on that directly, but there have been at least 3 papers I can think of that kind of back out the implicit cost of carbon from the Cash for Clunkers program, and you get numbers in the hundreds, like 200 to 300. So if you buy into the IPCC's social cost of carbon around 20 or 30, that seems kind of inefficient. Dave. Thanks.
I think one of the other things was the fact they structured it as basically a guaranteed minimum trade-in instead of a rebate like what there are for electric vehicles. So it was just basically taking clunkers off and giving, if it was only worth $1,000, they got $4,500. So I think another key element of that was that structure of the sort of guaranteed minimum trade-in.
So you're suggesting a redesign would be?
It was a policy failure from that standpoint that helped drive this as well as the
Right. Wait, so sorry, what would be your redesign, but that kept the fuel economy?
If you wanted to encourage higher, at least the same average MSRP or higher,
right.
You have $4,500 that is on top of what they would get traded without having to destroy the vehicle. So if they got even $1,000, they get $5,500 instead of just
Yeah, so I hear you on that, right? But if you still, nevertheless, if you have the restriction, it has to be 22 mpg or more. You need them to buy the hybridized versions and not the Corollas. Perhaps.
The package structure. And the interesting thing is that at that time, we had leasing that went away, the auto industry, because of the financial health. And then we have
Right.
So false results.
Yeah, that's fine. Yeah. I mean, so I agree that you could, if we could rewind time, we could go back and you could throw more money at people and see if they then buy the Priuses. Right. Right. If I were going back in time and my primary goal were stimulus, I think I'd probably abandon the fuel economy component to it and then see if there were other ways to reduce carbon. Now, we all know the politics of that, so I don't know. Okay, so I'm glad Dave jumped in because I'm basically done. So I guess kind of happy news and sad news in some ways. I guess depending on who you are. The happy news is it looks like at least in the short run there isn't a large rebound effect. But I think so I'm not in a policy school and I'm not a political scientist, so economists often speak in areas they shouldn't speak. So I want to be very careful and not say too much. But if there is a policy lesson coming from this little country economist, I think it would be that when there are dual policy goals, even if both of them are individually worthy, it could sound good to stick them together, but it could possibly backfire. And I've had this discussion with my co-authors. One of my co-authors is adamant that he would have seen this and he wouldn't have made this mistake. I'm not entirely sure if I were at CEA, if I wouldn't have made this mistake too. So there is an element of Monday morning quarterbacking in this, I suppose. But nevertheless, it seems like a reasonable policy message. Yeah. Yeah, good point. Yeah. Mm-hmm. So the question is, what covariates are smooth through the discontinuity? Or go ahead. Now.
You said it better than me. So I'm wondering what covariates were smooth through the discontinuity, and we can check income levels.
So let me build up your question a little bit too. So one worry about the RD design is you want to make sure that everything that's causing that outcome variable is smooth through the discontinuity. We can't see everything, but we can see a certain subset of things. And so what you want to do is you want to check to see if they're smooth through the discontinuity. So these are called like falsification tests or placebo tests. So two things. One is if you go, we have a remarkably nice set of information from the DMV, but we don't have demographic characteristics from the DMV. They don't know your race or stuff, right? But at that same time, there was a survey called the National Household Transportation Survey that we can't link up to our observations, but you can then see characteristics of people through the discontinuity. So a cynic might say, oh, the government knew that people that were 18 were different from 19. We want to help the 18s in some sense, right? So if you take most any NHTS demographic variable and plot it through the discontinuity, it's smooth. And we've got pictures in the paper, so you can look at it and decide, if you think it's smooth or not. The other thing is, for the stimulus result, we looked at the VMT in the year before the program, so in 2008. And same deal, like the pictures in the paper, I view it as smooth, look at it and see what you think. Ideally what would really be nice from our perspective is if DMV knew a lot about all of us, right? So then I could see if everything about us is smooth as the discontinuity. Anything we thought of where we could get data to see if there's something special about the 18th versus the 19th, we weren't able to find anything.
And you keep referencing you see it as smooth. Like when you did the regression, the coefficient associated with that change was not significant, I assume.
Okay, so that's a fair point. So, fair point. So if in the NHTS the sample size is sufficiently small that they're big standard errors anyway. So okay, let me step back. So like the typical regression discontinuity person, like if you're a religious regression discontinuity person, you want to see these falsification tests and no stars on the table, essentially, right? In the NHTS tables, you see no stars. In the VMT, you do see some stars, but they're economically rather small. So, take from that, I guess, what you want.
Hi. So I remember actually the Cash for Clunkers program. I still drive my clunker currently, but do you feel that possibly the feedback, or what was it? I'm sorry, the pull forward effect that you were discussing, being more short run than I guess was the most positive result? Could it be maybe like a test drive effect where during that 8-week period, I sort of test drove some cars, was thinking about doing it, and then the program just ended. So then possibly those people who then bought in the short run had sort of already been primed to purchase a car. And so then, went forward and then bought within
right.
sort of 18
So I think for that story to play out, you would need the barely ineligibles, even though they knew that they weren't going to get any subsidy, to still do test drives.
I ended up keeping my car anyway,
but you were eligible.
I was.
Yeah.
And then the program ended.
Yeah. So I think, so there could be something wrong with this result, but for it to be wrong, basically you need to tell a story about why the people who are just barely ineligible and weren't affected by the program are not the right comparison group for those that are barely eligible. So that's the kind of story you're looking for, yeah. I'm sure our referees will find one.
So what caught me when I saw the article in the Wall Street Journal, first of all, it was an interesting topic, and your name was on it, so I especially wanted to find it. But what sort of was fascinating is there's an anecdotal piece of data that changed my view, in that my son had a friend who actually traded in an Explorer and bought not a Corolla, but a Nissan Versa equivalent. And so it almost made me think that this shouldn't be cash for Corollas, I thought that was very clever. It's actually probably cash for middle class and up kids trading in their hand-me-down Explorer that was junk for a car to go off to college or drive in high school. And so I wondered I don't recall in there if you looked at any of the demographics or you had any of that data available to see if that anecdotal piece of data really was more broad-based, because a lot of the Explorers that were worthwhile to trade in for $4,500 only would have been traded in if they were worth a lot less than $4,500, and it was a good deal to do so.
Right.
And those were one of the most popular cars in the nation, and hence they were handed down. And I just wonder how much that analogy may have held and how much data you had.
Yeah, so we haven't done anything directly on that because we don't have demographics. I mean, some have argued that Cash for Clunkers was pretty regressive in the sense that, the only people who could take up the program had to buy a new car. They couldn't buy a gently used car. So, for example, the Dallas-Fort Worth program, you can buy a gently used car. Like I think it has to be like within the last 4 model years or something like that. And then the other knock, and I'm not sure if there's good evidence on this or not, so I won't say which way it goes. I'll just kind of throw it out there, is that you're trashing 677,000 potentially used cars. And so there's been conjecture that caused used car prices to go up, which would hurt the people who would be buying used cars, the poor. Although I want to say I've seen some work suggesting that that's such a small share of the used car market, it didn't have a big effect. So I don't know numbers on that, but that would be interesting to look at. You're nodding your head, so it sounds like you know what numbers are on this, or?
Well, I think what's driven up used car prices is just the decline of new car sales, and there's a supply. Sooner or later, new cars are going to be used cars, there's a shortage. That's probably small, 16,000 here.
Yeah. There's been some really interesting work by Arthur Van Bentham, who's at Wharton, and Mark Jacobson at UC San Diego, that basically says when you see these fuel cafe standards, there's anticipation that you're not going to be seeing the Explorers anymore, and so therefore people they fail to scrap the Explorers, and so it could be this kind of perverse effect where the anticipation of cafe keeps the dirtier cars on the road longer.
So I'm missing a piece that I would like if you can explain a little bit more, that these results apply for the people that are on the discontinuity and arranged maybe to both sides. But what happened with the extremes? So the people that was on the very left side, what happened in that piece?
Yeah, that's a really good point. So everything we are saying in terms of like that I believe the causality is all about comparing these guys to these guys. So quite literally, so you sound like you know this type of stuff, but quite literally, this is the local average treatment effect, right? So all we can really say is for these guys that are here. Now the size of, so the question is, are these guys and these guys similar? Or sorry, are these guys and these guys similar? Are these guys and these guys similar? We can't say anything, right? The further you get away from that discontinuity, the more your identification strategy isn't very clean. So when we do, I should make this clear if I didn't, I apologize. When we do this calculation, we're basically assuming that that local average treatment effect applies to everybody. And if you think that it doesn't, apply to these people here and these people here, then you should, not believe our results as much. So we're very clear in the paper. I apologize if I didn't do as much. This is definitely a back of the envelope calculation. We really believe this number, and then this is kind of an extrapolation which you can choose to believe or not.
Progressive in another way, in that the only people who really felt comfortable buying cars in 2009 were either secure in their jobs, could pay cash, or they had high FICO scores because financing was getting much tougher, and there was no leasing. So it further stratified who could really afford to do this.
While you're grabbing, one thing I'll just say is I know the Dallas-Fort Worth program, because we're doing some work there too, and that's means tested, and they're thinking about trying to understand what the effect would be of loosening that means testing restriction. So I think there is real sensitivity to the regressivity.
At the beginning, you mentioned that there was someone who said we should not worry about the rebound effect. Do you know what his reasons were?
So Rabson and Gillingham, what they do, so the rebound effect could apply to any durable good. It could be appliances, any durable good. So what they do is they survey the literature, and it's kind of a meta-analysis essentially. And I forget what number they center on for cars. I want to say it's around the 0.2 region. But I think their focus was don't worry so much about the backfire effect. So the backfire effect would literally say you increase fuel economy by 10%. It's not that you get less than a 10% decrease in consumption. It was that you get an increase in consumption. And so I think the real message is don't worry so much about the backfire effects. I believe, I haven't read the David Owen piece in a while, even though I used that screenshot, but I think it suggests there could be a serious backfire effect.
Is it possible to work this backwards to figure out what would be a good, limit to achieve those dual policy goals, if that is ever possible?
I don't think I have much intelligent to say beyond. I guess that what I'd say is, if you're really looking at stimulus, don't put the fuel economy restriction on it. And then as far as the dealing with emissions, I'm going to kind of repeat the standard economist line, which is probably increase the gasoline tax. Although there's been some interesting work about gasoline tax versus CAFE standards that a lot of people have done, and I can point you towards if you're interested in looking at that. So, so the knock on CAFE standards, or generally for increasing fuel economy, is that you could get this rebound effect. And moreover, it only affects the margin of buying cars. It doesn't affect the utilization margin, right? So the price per mile isn't being internalized. So the standard economist argument is, well, let's get the tax of gasoline right, so every mile you're driving, conditional on what car you bought, you face those externalities. There's been some recent work by Han Alcott, I think it's coming out in Restat soon, Review of Economics and Statistics, that tries to basically back out, is there a behavioral effect where we don't fully internalize the fuel economy savings of buying a new car? And he backs out something which is kind of close to a discount factor. I think it's Alcott and Wozni, W-O-Z-N-Y, in Review of Economics and Statistics, if you want to track it down.
Hi, Professor Tu. Very good presentation, and personally I like the RD design. since I used it before. So my question really is about some details, not about the methodology. First, the less spending here, has that accounted for the factor that people may purchase more cars, other than just pulling forward? How is the pulling forward factor included in this calculation?
Sure. So the idea is if we can nail down the pull forward window, then we're going to take, okay, those are the people who would have bought anyway during that window, which we're going to take 10 months, although we do robustness to slightly more and slightly less. You take that window, and then you ask the question, counterfactually, how much the barely eligible would have spent if they had behaved like the barely ineligible. So what is that doing for number of cars? It's basically taking the number of new cars bought by that set of households is going to be constant over that 10-month period with the policy and without the policy.
Okay.
So is that what you're asking, or I have a feeling not quite?
Sort of. Right now, I kind of understand more clearly how do you do the calculation. Second question is, with this less spending or savings for those people, I'm sure they will spend on other products. So that's second order rebound effects. Do you have a guess on?
Yes, that's a really good point. So keep in mind, these people are getting subsidized, and they're still, with that $4,200 subsidy on average, spending less on cars. So they've got more money in their pocket, so to speak. They're not spending on the cars, right? So could there be another macroeconomic effect, depending on what multiplier you think is out there for overall spending? That could absolutely be the case. So we're not speaking towards economic stimulus outside the auto industry, and there could have been some because these people had more money in their pockets. We're speaking towards just money to the auto industry, which we argue was probably the legislative intent of the policy to begin with. But it's a very fair point. There could be other macro effects that we can't measure.
Hi. So I guess I'm more concerned with the emissions reductions of the legislation, but do you feel that they were too conservative starting at 22 mpg? I mean, do you think that they possibly could have gone up to maybe, I don't know, 28, 25, something like that, at the very least?
So the emission calculations were done in a paper by Chris Knittel, and also there's another paper by Shan Lee. And what they do is they basically back out how much, when people would have gotten rid of their cars otherwise. And so it's kind of a cost effectiveness analysis. How much was paid in subsidies per ton emitted? And that's how they get numbers in the range of, I think, 150 to 300 or somewhere in that range. I mean, the point is it's above 30.
Any idea the total value of the subsidies?
Do you mean how much money was spent? Or?
Yeah, across these 6, 7, 7, 2, 3, 8.
Oh, it was just under $3 billion.
Okay.
Sorry, just one last question on the number of problems and number of policies, instruments. So I assume when this policy, Cash for Clunkers, was in place, there are other policies addressing the fuel efficiency problems. So they do have multiple instruments to address multiple questions, multiple problems at the same time. Do you think it's a bad combination, or can you just say that?
There is this general view, if you want to target two objective functions, use two instruments.
Yeah.
The major policy that came after this was a revisiting of the CAFE standards. And I think that, Dave is nodding, and I think that would be viewed as kind of the major policy targeting. Although, as I alluded to at the beginning, there are vehicle scrappage programs kind of all over the country, smaller scale.
And so Europeans have a good example. You can effectively regulate the CAFE standard or emission standard because there's surely equations that go from fuel economy to emissions level. And so they have an overlap somewhat, but they approach the two objectives by higher gas taxes to change behavior, as you were talking about, as well as the cafe and or emissions aspect of it as far as the technology push in the vehicle manufacturer. And that seems to be pretty effective at going in those two objectives. And I think the cafe has a much bigger chance of a rebound effect. It can actually stimulate or encourage more sprawl because now an F-150 is aluminum and gets 25 miles to the gallon. All of a sudden, you can afford with that type of vehicle that you prefer to go out further and have the same percentage of your income or disposable income spent. So I think there's much more danger. It's just politically more correct in our situation here to not have a gas tax that's much higher, even inflation index.
Let me ask a clarifying question where when you're comparing the pull forward window, and there you're looking at the barely eligible and the folks who stayed within the 2-month window, and then 10 months beyond, is right. Maybe a couple perhaps before. So here, did you also do the smoothing checks for the group that actually benefited from the program versus the group that you used for making the pull forward window assessment?
That's a good question. I don't think we did the smoothing checks until we got to the end of the window.
Mm-hmm.
We could do that.
And the reason I'm asking is, there is an implicit assumption here that the group that benefited from the program is same to the group that did not benefit but was still barely eligible 10 months from there. But maybe there are factors, behavioral readiness,
sure,
pre-past experience,
right,
that could make possibly that group a little bit different from the pull forward 10 months.
Yeah, I'm sympathetic to that. So I think that's what you just said is exactly the reason we wouldn't want to do the dollar calculation on this picture. Because you're right, these people could be a little different than these people. So the reason we wait until it looks like, quote, the ineligibles have caught up is because then you're getting the probability of purchase is identical across the two. And so if there's a problem with that empirical approach, you'd have to tell some story about why the program would make some subset of these more likely to purchase and some less likely to purchase. So so the reason we wait to do the dollar calculation until the purchase probability is the same, is for exactly the reasons you say.
But then isn't this sample of the circles on the left side, or even the triangles on the right side, isn't this a portion of the barely eligible that actually did not go through the program?
Yeah, so some of them did not go through the program, absolutely. So this is everybody who's eligible, whether they bought or not.
Mm-hmm.
And obviously many didn't, right? 95% didn't buy.
Mm-hmm.
Right, so this is everybody and this is everybody.
And so
everybody in Texas that has a clunker between 10 and 26 is in this.
We still have time for just one more question. If not, we have time for
All right, thank you very much.